Alright, so today we're going to start with section 5.5 Fibonacci sequence. This sequence is given here. It's used a lot in nature, but we can see you get the next term by adding the previous two. So for example, 1 plus 1 gives you 2. 2 plus 1 gives you 3. 3 plus 2 gives you 5. 5 plus 3 gives you 8. 8 plus 5 gives you 13. Continue on. So the previous two terms add to give you the next term. Okay, so move that back out of the way. And then the golden ratio, we talked about, we did this in our notes, it's in your textbook, is the exact value is 1 plus the square root of 5 over 2, which is approximately 1.618. And we're going to be working with some of these values in the next problems that we'll work. So the first one is, if you're given the 16th Fibonacci number, and they tell you it's 987, and then they tell you the 17th number is 1,597, what's the value of the 18th one? Well, let's think about that for a second. We don't know the ones in front of that technically, but we know the 16th, right? So this one's the 16th one. We know the 17th one, which is 1,597, and the question is, what is the 18th one? So what do you think we do there? Yeah, just add the previous two. So you'll add 987 to the 1597, and we find out that we have 5,084 is our 15th term. 2,584. Okay, good. So the idea and the concept of Fibonacci is not too difficult. Our next one, the notation is just going to be a little bit different to you. So this time they tell you the 22nd Fibonacci number is 17,711. The 24th is 46,368. So they're saying, what's the one in the middle? Let me kind of sketch that out again. So if I had, there's numbers in front of it, but I get to the 22nd one. This represents the 22nd Fibonacci number. I don't know the 23rd. That's the one they're asking. But I do know the 24th term, which is 46,368. So, what do you suggest for getting our 23rd term?
Just subtract.
Yes, very good. So you would just subtract. So you would take the 46,000 number and subtract the 17,000. So 24th minus the 22nd, we'd subtract those to find out that the 23rd is 28,657. So good job there. But like I said, Fibonacci sequence is stuff that you'll be asked to do with it. It's not challenging. It's kind of more of a fun, interesting thing. What's the next equation in the pattern? So we're looking at a pattern here, and we see it's 1 plus 1, 1 plus 1 plus 2, 1 plus 1 plus 2 plus 3. So on the left side, what's going on? Fibonacci, right? So 1 plus 1 plus 2 plus 3 plus 5. What was the next one for us? Plus 8. And then let's look at the right hand side. Going down, the first number is 2, 3, 5, 8, 13. What's the next Fibonacci? 21. Good. And if you're not sure and aren't familiar with it yet, you can go back up there, or you can just calculate it in your head. And then, what's the next pattern? Minus 1. Everything else at that point was minus 1. So good. Number 9, on the left-hand side, let's see if we can figure out what's Initially, I tried to look at it like it was Fibonacci like above, but we can see that above that Fibonacci was 1, 1, 2, 3, 5, 8. So let me just, sometimes if you're dealing with these Fibonacci patterns, it helps to write it. So I have 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144. Okay, just so we're looking at that. Now look at those and see if we can establish anything. It goes from 1, then on my second row, it goes from 1 to 2. And then it goes from 1 to 2 to 5. And I'm only zoning in on the left side. But if I go from 1 to 2 to 5, what's it look like it's doing? Every other one, so that means 13, is that the case? Yes, we're checking our third one. Then after that, 34. So what it's doing is it's doing every other one. So 1 plus 2 plus 5 plus 13 plus 34. What skip 1 with 34 in our next term would be 89. Okay, good. So we figured out that the left-hand side was every other Fibonacci term. And let's look at what's going on the right side. You get 1, 3, 8, 21, 55. What's that look like? The ones we didn't highlight, right? So 1, 3, 8, 21, 55. So what's our next one? Yeah, 144. So on the section 5.5 stuff, when you're specifically asked to look at patterns with Fibonacci sequence, kind of jot your sequence down, and if it's not intuitive and doesn't match it exactly, kind of look for something like this. Is there patterns in it? Did they skip every other one, or did they skip 2 and write every third one? Or just kind of, my advice is to write down Fibonacci so you can see it and just kind of look for patterns in it. The next one is just the Lucas sequence. So what's the next term in the Lucas sequence? For you to be able to do that, I have to give it to you. And Lucas sequence is 1, 3, 4, 7, 11, 18, 29, 47, 76, and 123. What's it look like to you? Yeah, and the previous two. So kind of like those Fibonacci, but it doesn't start us out with the 1, 1. It just gives you the first couple ones, and then you still add the previous two, and it's just a distinguished sequence. So 1, 3, 1 plus 3 is 4, 3 plus 4 is 7, 4 plus 7 is 11. Keep going, but now it wants us to know the 11th term. So how many did I write? 1, 2, 3, 10? So I need the next one that I didn't write. So what would I do? Add 76 to 123, and that should give us our next one, which should be 199. Thank you. 76 plus 123 is equal to 1. Okay, good. So that's it in chapter 5. Section 5.5 is pretty easy, nothing too difficult there. 6.1 is going to be familiar to you as well. We've already talked about these rational numbers, anything that can be written as a fraction. Integers, anything on the number line, positives and negatives included. Natural numbers, whole numbers are all of the natural numbers and 0, and then the natural numbers are just the counting numbers. So that's, name an integer between 4.5 and 5.5. You can pick any one, but an easy one would just be what? 5. Yeah. We could have said 4.7. We could have said 5.1. We had a lot of options, but it's easy just to hit that whole number between 4.5 and 5.5. Every natural number is positive. Remember, the natural numbers are the counting numbers. True or false? True. Okay. Every integer is a rational number. True or false? Yep. Look in there. Every integer is included in the rational. So, true. The next just says use an integer, a positive or a negative number, to represent the description. Height of New York Times. Oh, I have these. Let me take these off so you can try it. So, go ahead and be looking at those. Height. So just put a positive or a negative number, basically. What would you use to the height of New York Times Tower? If they tell you it's 10,046 feet, since you're talking about height, would you use a positive number or a negative number? Positive. So the positive integer would be 1046. 1,046. All right. If I told you the height of Mount Arnold is 5,436, which integer would you use to represent that? Just 5,436. What if I say the population in DC decreased by 31,841? What would we say? Yes, negative 31,000, because it went down, so it can be represented with a negative value. 5 degrees below Fahrenheit, negative 5. You won't have a degree there, but the next thing you'll be asked to do is to graph each number on the number line. The easiest thing for you to do is put numbers in order first, if it helps. 1, 2, 3, 4. I have 5 of them, so I put 5 little tick marks over there. When I'm ordering them, remember the negative 6 is the smallest one, then negative 4, then negative 2, then 3, then 4. And my number line is not to scale. It's not to scale. I just put them up there. If it's more convenient for you to draw it to scale, then you can do so. Since these numbers are small, it would be easy to do that, but if I gave you like negative 56 and negative 20 and positive 70, like it wouldn't be very wise to try to scale it out, but if it helps you, it helps you. Find the additive inverse and the absolute value. Remember, additive inverse means when you take two integers, you add them together, you get 0, right? So the one we did in our notes was negative 3 and positive 3 are additive inverses. They're opposites. That means when you add them together, you get 0. So what's the additive inverse of negative 2? Positive 2. Good. What is the absolute value, like this, of negative 2? Positive 2. Good. So the additive inverse was 2, and the absolute value is 2. For 6, what's the additive inverse of 6? Negative 6. Good. It's the opposite. Our second question is, what's the absolute value? That means what's the distance from 0 on the number line to 6? How many units? 6. What do we know about absolute value? Always, always, always positive because it's talking about distance. So, good. Now we're just going to do a little bit of comparison. Select the lesser. Select the lesser. Which one's smaller? And now this one, you can do this however you want, whatever's better for you. But when you start thinking about money, people are really good with money, okay? Which one means you're more broke? If you owe $12 or if you owe $4? 12. Yeah, so you don't want, that's the lesser value. So being in the hole $12 versus being in the hole owing somebody $4. So that's the lesser. What's the lesser out of the next one? -8. Also, the lesser is also the one that would be further left on a number line if you put it there. The one that's more negative, yes. Alright, so for this next one, we're actually comparing 3, but we're comparing it to what is the absolute value of -4? 4. So we're really comparing 3 and 4. Which one's the lesser of those two? 3. Good. So be careful there. You probably want to calculate that. Simplify it before you actually assess it. This looks like we're still doing the same thing. Alright, so what is the absolute value of -3? +3. What is the absolute value of -4? +4. So, which one's lesser? 3. So in this case, we would say absolute value of -3 is the lesser one. If we had to go back to the original. Or if in Math Lab it asks you, go ahead and you can evaluate that. So if it wants that negative absolute value for you to tell the choice of those two, pick it. And if it's like, what does that simplify to? We would say +3. All right. Now 49, don't let this trick you, because what is the absolute value of -6?
6.
+6, but this negative is just sitting out front, so that's actually -6. Same thing here. This value is +4 when you evaluate the absolute value, but because that negative's out front, it's -4. So now which of those is the lesser? Yes. So I would either say this one is the lesser, or if in Math Lab it asks you to evaluate that, you would say -6. This is really just asking absolute value of, so that's absolute value of 2, comparing it to the absolute value of 6 minus 2, which is 4. And that's really just comparing absolute value of 2 is 2, absolute value of 4 is 4, so which one's lesser? 2, or if I went back to the original problem, it would be this one, which simplified would just be 2. Good. Determine true or false. So, on 57, what's the absolute value of -6? 6. What's the absolute value of -9? 9. Is 6 less than 9?
Yes.
And this is what we used to do in old school. I make it into a Pac-Man, and then does Pac-Man eat the bigger number? Because he likes it, he'd say, yes, this is true. However you do that. Some people did alligator, I did Pac-Man when I was in school. So, 59, what's the absolute value of 8? 8, but this negative sitting out front, so that's just -8. What's the absolute value of -9? Just 9. So what you're comparing is that. So what you think? False. Alright. Absolute value of -5 is 5, but because the negative's out front, that simplifies to -5. Absolute value of -9 is +9, but there's a negative out front, so my comparison is -5 greater than or equal to -9? And that's true. And the last one here, that's going to be absolute value of 1, absolute value of 4, which that means absolute value of 1 is 1, absolute value of 4 is 1 greater than or equal to 4, and that's not true. So that's false. So that's section you should be pretty familiar with too. So this next section we're going to move to is section 6.2, and this one, if anything, is going to be the one that's going to take us the most time. So before we start working the examples, I want you to take a few minutes. These are our rules. So if you have the same sign, you're going to add and keep the sign. If you have different signs, meaning one's positive and one's negative, subtract and take the sign of the larger number, which basically means the absolute value of the larger number. This is for the top with the stars up there is your rules for adding and subtracting. This little symbol down here is going to be rules for multiplying and dividing, which we use a little triangle rule to represent. And I will show you how this out. Alright, so we're going to work with these. There's a lot of different ways. Now, I like to do it this way, and I'll be consistent with it just because patterns and things like that, consistency work for people. If you do it a different way and you're fine with that, I'm alright with it, okay? What I like to do is I always, when I'm adding or subtracting, I like to be able to use the rules in general so I don't have to do anything too tough with that, but I like to circle. What I do is I circle the number and the sign immediately in front of it, whatever the sign is. Circle the number and the sign immediately in front of it. Because when these things get to be really long and we start doing order of operations, like I need to be able to zone in on what I'm looking at. And all that extra stuff sometimes confuses. So circle the number and the sign in front of it. Circle the number and the sign in front of it. So now your rule is, because it's an addition and subtraction problem, is same signs, because they're both negative, add and keep the sign. So you add the numbers and keep the sign out front. So we would just say 12 plus 8 is 20, keep the sign. With that same mindset, circle the number and the sign in front of it. What if there's not anything shown? What's it known to be? Positive. Circle the number and the sign in front of it. So ignore everything else at this point. Are they the same or different? Different. So subtract just the numbers themselves. So 16 minus 12 is what? 4. Ignore the signs. Which one's the bigger number? 16. So when my note up there says subtract and take the sign of the larger number, so we're going to do the absolute value of that. But the 16 is the larger number, and it's the one with the negative. So subtract, take the sign of the larger number. Which we know we're doing the absolute value there, but we're the absolute value of the larger number, but we're just going to, for the purpose of pushing through, we're going to do that. Now, here's the other thing. Any time you see this double negative, that's a red flag. Red flags must always and forevermore be taken care of first. Anytime you see it, change your sign. Take care of your red flag. Now that red flag's taken care of, let's do our circle rule. So, circle the number and the sign in front of it. Circle the number and the sign in front of it. Same or different? Different, so subtract. 12 minus 1 is 11. Which one's bigger? If 12 is bigger than 1 and it has a negative sign, so keep the sign. only work with 2 at a time. Different signs, so I subtract those. 11 minus 5 is 6. Take the sign of the larger number. 11's bigger, it's got a positive sign, so I leave it positive 6. I rewrite the rest of my problem, plus 3, and I do the same thing, which this one's easy, 6 plus 3. But even if I did my circle of number and the sign in front of it, same signs, add and keep the sign. Just so that you can see this rule works. If you do it, you do it, you do it. I mean, you didn't necessarily have to do that there because it was easy, but to be consistent. What about 15? Talk to me about it. Red flags. We have to take care of red flags first. So here's a double negative, so change. And then here's a double negative. Minus a negative means change to plus. Well, now, circle the number and sign in front of it. 12 plus 3 is 15. And then I have positive 15 and plus 5, which is just going to be 20. Now, if we did circle rule to that right there, we're still going to get positive 15, positive 5, which is 20. Okay, so we'll do that for all adding integers. Adding and subtracting, the 2 stars up at the top are the rules for adding and subtracting. For the next one, starting with number 19, we're going to do multiplying and dividing. If you multiply a negative times a positive, you get a negative. Or the reverse of that, a positive times a negative, you get a negative. If you multiply a negative times a negative, you get a positive. So let's just look at this. I'll show you what that triangle does for us. What's 12 times 2? 24. So multiply it just like you normally would. But this rule is, if I take my finger, let me get something. I take my finger, and because this one's a negative and this one's a negative, I cover up both of these, what's left? Positive. It means my answer's positive. $18 divided by 3 is 6, and then a negative divided by a negative, so a negative divided by a negative, cover those up. So what's left? Positive. $36 divided by 6 is 6, but now I have, this time I have 1 positive and 1 negative, so I have 1 positive and 1 negative. If I cover those up with my hand, what's the sign left? Negative, so that means this one's a negative. Or using your rules, a positive divided by a negative is a positive. A positive divided by a negative is a negative, excuse me. Okay? Alright, now we take the basics and we start merging them together. We do order of operations. Please excuse my dear Aunt Sally, right? Parentheses, exponents. Now, multiplication and division, left to right. These two are basically on the same scale. If division comes first, you do division first. If multiplication comes first, you do multiplication. They're on the same level. And then you do addition and subtraction. And addition and subtraction are on the same level. If addition comes first, you do it. If subtraction comes first, you do it. But it goes in order left to right. So parentheses first, exponents first. Then you would do multiplication or division next. And then you would do addition and subtraction. So when we have parentheses in this next one, we're going to work from the inside out. So I'm going to work with the innermost first. So parentheses is priority in PEMDAS, right? So here I am. That's a subtraction. I'm in this first one. Circle the number and the sign in front of it. Circle the number and the sign in front of it. Because it's a subtraction problem. Different signs, subtract, take the sign of the larger number. Bring everything else down. Start over. I have to do inside parentheses or brackets. I have to do that first. So circle the number and the sign in front of it. circle the number and the sign in front of it. Different signs, subtract, take the sign of the larger number. Positive 4, positive 3. And my last step is multiplication. So now we have a multiplication rule, and that's a different rule, that's a triangle. So 8 times 3 is 24. If you cover up a negative and a negative times a positive is a negative. Okay. Order of operations says come do multiplication first. So negative 3 times negative 2 is a positive 6, right? Now bring everything else down. Bring down negative 4, bring down plus 5 squared. We did parentheses first there. Exponents would be next. So my next one is to evaluate this. What's 5 squared? 25. Now, addition and subtraction is left to right. So starting on the left, I have a negative 4 and a positive 6. Different signs, subtract. Take the sign of the larger number, which is just going to be positive. Bring down the rest of the problem, and the answer is 27. Alright, for our next one we have, we're going to do inside the brackets first. And inside the brackets, what's more important, the exponent or the subtraction? Exponent, so we want to do this one first. Whoops. We want to do that one first, which is 16. But while we're in there, we can go ahead and we can evaluate this one next. So positive 7, negative 3, different signs, subtract. Take the sign of the larger, which is a 7. So I have this. I'm going to leave this alone. I'm still working in the parentheses, so my next thing is to do this. 16 plus 4 is 20, so all right, order of operations, what should we do next? The multiplication or the subtraction? Multiplication. That's multiplication, so we need to be here. And a negative times a negative is a positive. Now here we're doing subtraction, so if I circle the number and the sign in front of it, I have different signs, subtract, take the sign of the larger number. Okay. So now we have a division problem. We want to simplify everything in the top, simplify everything in the bottom, and then divide. So for this one, you have circle a number and sign in front of it. Different signs, subtract. Use the sign of the larger number when you ignore the sign. Circle the number, the sign in front. Same signs, add and keep the sign. Up here, we have multiplication. Negative 3 times negative 4 is a negative times a negative is a positive. And then now we divide. 12 divided by 6 is 2, and a positive divided by a negative is a negative. Alright. We want to come over here, do exponents first, because these parentheses are just represent multiplication, so the exponents are going to come first. What's negative 2 squared? What's negative 2 times negative 2? Positive 4. Good. So that's just gonna be, let me bring this down, I'm gonna leave it alone. That's -3 times +4. And then I also wanna go ahead and do this one. Well, now that negative is not in parentheses. There's a big difference between this and this, right? -3 squared means -3 times -3, which is +9. But this one means 3 times 3 with a negative out front, which would be -9. So in this case, that negative is just out front. So 3 squared, which is 3 times 3, is 9, and that negative is just out front. Bring down +9. All right, in the top, let's go ahead and do, what's 2 times -5? -10. What is, whoops, 3 times -4? -12. 3 times 4 is 12, and negative times a positive is a negative. You can. It's okay if you do it, and if not, it's fine. But what happens on the bottom? They get 0, and in math, we can't have a number, you cannot have a number divided by 0. This means it's undefined. Can't have division by 0. All right, our next section is just going to ask us about properties. Okay, the first property is, what did we say when we had +9 and its opposite? What were those called? Additive inverses. So good, this is what is it when you start with 9 or start by something and you multiply by 1 and you get itself back? It's identity for sure, and then you just say, oh, it's multiplication, so it's multiplicative identity. So when all these parentheses, I'm looking at 54, 52 and 54, I know I'm going to have to decide between commutative and associative, and those can be tricky. And what did I say? Ignore everything and read across 3, 5, 4, 4, 3, 5. Did it change order?
Yes.
So commutative. Commutative starts with C. Commutative. You can't always just assume that the one with parentheses is associative. It's all about the order in that one. So 54, when we look at it, drop parentheses and everything else and just zone in on the actual value. 642 equals 642. Associative, because all it did is change the parentheses. Move the so that was associative. Good. 69 and 71 is basically what we just talked about a minute ago, but this time we're going to do it to the 4th power. If I have this one, it means I have a negative out front, but then I want to do 3 multiplied by itself 4 times. So 3 times 3 is 9, times 3 is 27, times 3 is 81, but this negative is out front, so that whole answer is 81. Where this means -3 times -3 times -3 times -3 is 81, but then when you have what's a negative times a negative? Positive, and then that's positive. So then what's a negative times a negative? Positive, so what's positive times positive? Positive. The other thing you need to know is if it's an even power, the exponent is an even power, you're going to have a positive value. If you have a negative number raised to an odd power, you would get a negative value. 81, 83, 85. That must be some graphs. Let me just see if I have a minute to kind of look. I'll stop this video. Go to your textbook and look at some of those if you want some graphs. We're just going to look at some graphs.